Hello again, I'm Dr. Sixbert from the Department of Crop Science and Horticulture. And today's lesson is proximal and remote sensing. But because this particular topic could be long, I've decided to split this topic into three parts. So part A, we're going to look at just proximal remote as applicable in precision agriculture. For by the way of introduction, we are saying that proximal sensing is when the instrument is placed within 2 meters of the target object. Unlike in remote sensing, where the instrument can be above 2 meters to thousands of kilometers from the object that is being sensed. So we go ahead and say that sensors are power-limited physical devices which can sense, process, communicate information to other sensors, base station, or storage. Now each sensor node has three main components. Component number one is the computation subsystem. Component number two is communication subsystem, and component number three is power subsystem. Now, these components can be summarized in a way of a diagram where we'll see how these components are connected. So we go ahead and say that this is the sensor subsystem, and this is the computation subsystem, and this is the communication subsystem, but also this is the power subsystem, as we've said. Okay, so here we have the sensor, and this will be fed by the power source, but the power source will also feed the microcontroller. So this will collect data and send to the microcontroller or external memory for storage, or to transmission to other central storage system, for example. Okay, so you can look at the details on your own. Now, the sensors that are appropriate for precision agriculture needs to have some characteristics or attributes. And here we are saying that before installation of sensors, the following factors need to be considered. One factor is the spatial scale. Now, how big is the field that it needs to be monitored? Now, here we are distinguishing the smaller and large fields as well, on the other hand. The time scale, and here we need to ask ourselves, for how long will the field be monitored? Will it be each hour, each day, each week, each season, or permanently? You need to be, take into consideration, because this will have cost implication. The other thing is the responsiveness. Do you want your sensor to give you data or information on real time or offline, meaning that it will store data for some time? Maybe after 15 days, you can come over to see what data has been recorded. The other feature is non-intrusiveness, meaning that the sensors, should they be visible or hidden or non-interfering with other systems? Now, that is important given the situation that, all agricultural fields are done in the open field. So if you are not sure that your sensors that you install in the field will be safe, then you need to think about hiding your sensors, okay, so that you minimize the chances of those sensors being vandalized. But also another thing that needs to be considered is the deployment and maintenance costs. Maybe you will need some technicians from a supplier, and this supplier could be based outside the country. And the maintenance charges, like do you have the technical expertise that is needed to keep regular maintenance, or you need to ship that equipment to the manufacturer for maintenance? So all these things are in precision ag. So here I've listed a number of types of sensors that currently are being used in precision or digital agriculture. And these have been placed under several categories. And one of the categories is the optical all light sensors. Now, these kind of sensors are capable of generating output by detecting modifications, refraction or reflection in visible light spectra. So simply, they just convert light energy into electrical signals. So here I've put a few of the optical sensors. And mainly these are cameras. So we have the near infrared camera, we have the red, green, blue camera, the two-color camera. But here is a multispectrum camera. It's called a multispec camera, meaning that it can sense more than 3 light bands. And here is the infrared camera as well. Another category is the electrochemical sensors. So these ones determine the changes in current, voltage, or composition of gas or liquid chemicals and convert those readings into visual outputs. And under this category, we have some types of sensors which we call biosensors. And these are chemical sensors based on recognition of biological substances. And this can detect things like diseases in animals or in plants as well. Now, in precision ag, the biosensor can be used to detect the diseases, as I've said, water toxicity, microorganisms, etc., etc. The third category is the electromechanical sensors. And these are devices which use both electric and mechanical components in carrying out their functions. So such sensors for precision ag include pressure flow, for example, pressure sensors for pressure or the flow or motion or levels or leak or accelerometer sensors. The fourth one are those for moisture and temperature sensors. And we say that soil moisture content can be measured through gravimetric, nuclear, or dielectric method. And under dielectric methods, the dielectric constants normally are the ones that are measured through what we call time domain refractometry or resistivity or capacitive or frequency domain reflectometry. Another kind of sensor which is new to the show is the smartphone. Okay, so the smartphone is a device which also consists of several sensors, which can assist also in farming tasks. For example, the cameras, smartphones do have cameras. They have image sensors, so they can take videos and pictures. But then they have the GPS, which can record location. But also they have accelerometers, which can detect the motion and changes in phone orientation. So the sensors now would gather data. Now this data can be stored in databases. Now once they have been stored, this data can work as backbone for high-end agricultural analytics and guide decision making. We go ahead and say that sensors can be used in precision ag for a number of purposes. For example, we have sensors which can analyze soil and can characterize soils as well. Okay, so under this category, we are saying that many sensors have been developed based on such techniques as near-infrared, spectral libraries, or thermal imaging for analyzing certain soil properties, for example, the nutrients, for example, nitrogen, phosphorus, and potassium, moisture levels, temperatures, compaction, etc., etc. Another use of these sensors is in yield sensing. So we say that when these sensors are combined with proximal ground information from sensors or airborne imagery and remote sensing can be used to build and feed machine learning models to predict yields of certain crops for the season, monitor harvesting times, and each growth stage for remotely located crop sites. So sensors, these proximal sensors, if you want them to work for yield sensing, it means they need to be combined with other equipment and technology so that they can be used to predict yield in the field. Another usage of the sensors is in weed management, and here we are saying that the same thermal imaging and fluorescence-based sensors and mapping real-time weed identification is useful in proximal differentiation and targeting of automated weedside spraying machines. Images and color-based sensors that are born on the UAV, or UAV means unmanned aerial vehicles or robots, can assist in crop and fruit assessment for ripeness, for example. So in this picture here, I'm showing a UAV, an unmanned aerial vehicle, doing spraying. It works in a sense that where these sensors sense that there could be weeds, because there has to be some mechanism to distinguish between weeds and crops, or where there are many weeds and where there are few weeds, so that these nozzles can adjust the flow quantities. Okay. Another area where the sensors are used in crop in precision ag is the disease detection and classification. And here is saying that sensors for monitoring meteorological or other biotic components can detect the disease onset. Okay, so this can help in upfront chemical spray before serious damage. Another area where sensors are imperative is in irrigation management. And here we are saying that sensors and actuators can manage demand-driven irrigation operations. So if you have this center pivot system fitted with sensors, that means they are capable of sensing whether the crop or the soil has or doesn't have water. And these sensors would trigger the actuators to operate the pumps and valves. And that is the beauty of sensors. They can automate the entire irrigation operation. Another area where sensors are important is in the greenhouse management. And here we're saying that temperature, light, humidity, carbon dioxide, airflow, etc., can be regulated by the use of sensors. Now, with the help of the wireless communication links such as 4G internet, Wi-Fi, Bluetooth, etc., greenhouses can be managed remotely and hence reduce the human interference, and in turn reduce the spread of diseases, because everything is done automatically and there are few instances where human needs to get into the greenhouse, and thus reduce the chances of this human spreading noxious insects or diseases into the facility. So, whereas technology remains an exceptional choice for agricultural sensors, and however, there are notable challenges to its implementation. Besides the beauties that we have seen about sensors, there are still a lot of challenges that need to be worked out by you guys. And so one of the challenges is that of standardization challenges, meaning that all these sensors carry different technologies, okay, which means that some of the sensors are very difficult to communicate with other sensors. Now we need some way of harmonization so that these sensors can communicate each other, even if they have been manufactured using different technologies and platforms. The other challenge is the poor information technology infrastructure and inadequate technical knowledge. Okay, now think about sensors. Many of these sensors need to be calibrated, and calibration needs a lot of knowledge in the background so that you have these sensors working properly, and that is still lacking really. Another aspect that is a challenge is the security. Okay, and importantly, corruption of data has been mentioned as one of the serious setback in the use of sensors. But also, we have safety of the devices, because most of these sensors are put into the open in the fields, and they are visible by strangers. So these strangers can be tempted to vandalize or steal these sensors. The other challenge is the complexity of certain stages of technology, like the need for calibration of some of the sensors, which I've talked about a few moments ago.